You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey everybody, welcome back for another week. So excited to be here.
It's so great to have you once more, Kirk.
Indeed.
Yeah.
Victoria will be back next week, but for now, you have two of us here, and I am going to kick things off. Last week, I talked about astrobiology and how likely we are to find particular forms of biology on other worlds.
Yep.
And
Gave me another existential crisis.
Are you over it
usual.
yet, or is it still like?
It's still percolating.
Okay. Well, I started that story by talking about a Redditor who had made the mistake of assuming human exceptionalism. And they believe that humans must be the end result, the pinnacle of evolution. And some of these ideas have their root in like religions, for example, that talk about humans being special and created apart from the rest of nature. And even though we now know that humans are a part of nature, you still find this idea pervasive in even the language we use. When we say animals, the assumption is often that we're talking about non-humans. You might say, that person's acting like an animal. It's like, well, humans are animals, so it's a weird thing to say. People talk about intelligence or language or consciousness as being those things that, quote, separate us from the animals. And naturally, you don't hear that kind of talk from scientists as much because, as we discussed on the show at times, other animals certainly have intelligence and language and consciousness. And heck, they even have societies and culture and traditions that they pass on and things like that. So biologists and zoologists and whatnot who have studied animals know that, no, they are very similar to humans, and humans are animals. I see this distinction between humans and animals a lot working with children. So if you tell a group of second graders that humans are an example of an animal, and you can just watch some of their heads explode, and they're like, no,
100%.
Yeah, they say humans aren't animals.
Animals.
And you're like, well, okay,
yes,
then
we are.
What are we? Are we plants? No. It's like, okay. And usually a few like well-read classmates will chime in, we are animals, we're mammals. And it's because they've studied it and they're excited to share that knowledge. It actually usually leads to some really fun discussions about how we classify animals and why, yes, humans are animals and humans are mammals. Well, the person we have to thank the most for this classification system is someone we have talked a little bit about on the show. That would be Carl Linnaeus. And I want to talk a bit about Linnaeus today. So Linnaeus was a fascinating guy. He lived in Sweden in the 1700s, and he was a botanist. And as we've discussed many times in the show, humans just love to put things into what, Rachel?
Boxes.
Yes, little boxes. I don't mean literal boxes. I mean figural boxes.
We do like putting things in actual boxes too.
That's true as well. But we love to categorize things as humans. Like we love it. And
we love
Linnaeus
finding patterns.
Yeah. Linnaeus looked at some of those patterns, and he came up with a system of binomial nomenclature that we use to this day. That's a big phrase. Binomial basically means two names. So we can define every species on Earth using two words or two names. Prior to this, species were all described by like essentially a long sentence that described them. They didn't have a scientific name. They had like a list of Latin words. And of course it was super confusing. And so what we now use is what Linnaeus came up with is the genus and species. Those are the two words that describes any form of life. So genus is the general group that they're in, and then species is a specific type of animal in that group. For humans, our binomial name is Homo sapiens. So you're familiar with many of these because we use them a lot, and sometimes it's like the only name we have for a species. You hear us stumble over these on the show all the time. But
all the
ones
time.
you might know, Tyrannosaurus rex is literally the scientific binomial name of the dinosaur, Tyrannosaurus being the genus, Rex being the species. It actually doesn't even have a common name other than T-Rex, which is just the correct scientific shorthand way of writing the longer name. So like we literally only know it by its binomial.
That's amazing.
Yeah, right. Carl Linnaeus was one of the people credited with showing that humans are simply animals, and is often called the first to classify humans into the animal kingdom, which is really weird since Aristotle proposed the same thing about 2,000 years earlier. That's 2 Aristotle references, by the way, in 2 shows in a row. And also, I want to point out, like, I'm not an expert on all world cultures, but I'm pretty sure, we're just talking about like Western scientific thinking. There's probably many cultures who also recognized that humans are animals thousands of years ago
100%.
and didn't have this weird, bias that we're not, no, we're separate. Now, it's pretty great that, he got this right, but old Carl didn't get everything right. And
of course not.
He had some pretty kooky ideas that were informed by the society he lived in. For example, he divided humans into subspecies that made a lot of people kind of uncomfortable because they're essentially what we would describe as races. And his descriptions were, I don't know how to say it, they were not scientific, but they were rather like cultural and political descriptions, like literally describing like, these people like look like this and they have this type of culture and this type of politics and this type of religion. And you're like, that has nothing to do with what species they are, Carl. But again, he was a product, of his, his own culture. And what's really strange, and what I want to talk about is that he also included some subspecies that are bizarre to us today that we would not recognize, subspecies of humans. He recognized both Homo ferus and Homo monstrosus.
What?
Yeah, so let's get to these. These 2 groups of humans certainly don't exist, at least not as distinct species. So I want to talk about what Carl got wrong. Let's start with Homo ferus. This is essentially the feral human.
Oh my God.
And these are humans who grow up in isolation from any society and are perhaps even influenced by wild animals such as wolves and bears. So basically we're talking about the wild child, right? I mean, we've there's been movies about like, even the Jungle Book, right, is literally a story about like this child raised by, wolves and bears, right? So this idea is found in many cultures and throughout history. I think it may speak to our fear of how thin the veneer of civilization is. Like the idea of a person who is raised truly wild both fascinates and also alarms us. And on a learning level, probably better helps us understand what is important to us about our societies. And it kind of outlines our fear of like maybe like how close to other animals we really are when we see that sort of wild side come out in people. There really aren't wild children or people out there in the woods, but these stories continue to fascinate us. And the archetype keeps ringing out throughout the centuries. I mean, just look at how popular Bigfoot stories are, right? And you can see that these...
like the Scottish Catman.
Yeah, it's this idea of these wild human creatures, or maybe in some cases
outside
actually
of society. And
like that's still a powerful idea.
They don't abide by common societal rules and everything.
And so Linnaeus, like I said earlier, was a product of his time. And in his thirst to classify everything, he seems to have classified things that don't even exist, such as Homo ferus.
Right.
Now, in his defense, there were several documented and popularized cases at the time of like wild children. And I don't know how accurate these or truthful these were, but they were being circulated as stories. Oh, in France, there was this, child that was found in the woods who was wild and stuff. And again, I don't know how accurate they actually were historically, but they were in the pop culture at the time. And because he was trying to be thorough as a scientist, you forget that like they didn't have all the tools to actually search the whole world. It was like if someone reported something to you and you're like, well, that sounds good. It's like, well, I want to be complete. I better include that just in case, right? So I guess it is.
I don't have a way to confirm this at the moment.
Yeah, it's kind of understandable that he wanted to include them in his catalog because it seemed like good information to him. But what about Homo monstrosus? As you can guess,
I'm going to say this right now.
Yeah.
It feels ableist.
Oh, yeah.
Gonna say that flat.
Oh, yeah. These are human monsters. In this case, the species group Monstrosus was a place to put the things that he didn't understand, right?
Okay.
And I'm taking the most charitable view here, but like, there were starting to be reports as people were traveling around the world more about meeting other people. And there was things that he just kind of didn't understand. Like there was people talking about meeting giants, like going to a place where there was these abnormally tall people that were taller than like all the other people in the world. And then some people might sail somewhere and find people that were really, really, really short. And he's kind of like, well, this doesn't fit into my nice, neat boxes. Speaking of boxes, there was also a popular cultural idea at the time that everything came in fours. You had to divide everything to four. So there was like the four humors, and there was the four different subspecies or sort of races of humans. And so when he encountered people, because obviously we all exist on this spectrum of diversity, but that was not the popular idea at the time. There was this much more simplified idea, probably informed by the fact that there wasn't as much cultural exchange going on. So he was like, well, I don't know what to do with these outliers, right? So he unfortunately put them in a group, basically calling them monsters. Not great, Carl. Not great. And like I said, it's easy to fault Linnaeus.
Bad look for you.
Yeah, for some of his ideas, but at the time, he was trying his best to define what a species was. And if you know much about science, this is something we struggle with even today. And he was at the very forefront of this, so you can see how it's easy with hindsight to look back and go, oh, how silly. But even the idea of what a species was, he was inventing, essentially, and trying to kind of come up with and figure out what it is. We don't necessarily agree what a species is today, to this day. We have a pretty good working definition, but again, the closer you look at stuff, you go, again, we said all the time, things don't fit in little boxes. Everything's actually on a continuum. So drawing a line between these two things and saying, this is species A and this is species B, it's probably more of like they kind of bleed into each other as populations change, so.
Right. Well, I mean, how many different species do we see like hybridizing, and creating a new species?
And there's even cases where we did most of this.
Distinct and
we did most of this work by just looking at things. And now that we have DNA analysis, I know from my work with birds and some of the papers I've read that there are certain times where they will take essentially a feather from different birds and test the DNA, and they'll go, oh, you know what? There are two different distinct populations, or maybe 4 or 8 populations of this one species, but they have a slightly different call. Maybe they don't interbreed even when their populations overlap. They have different wintering grounds. They have different behaviors. They eat different food. Like they look identical. And if it was in your hand, you could not tell it apart unless you did a DNA analysis. And you go, is that a different species?
Right.
Or is that a subspecies? Like, where do we draw these lines? Even today, we don't necessarily know, or we argue over where to draw these lines.
We argue all the time.
What they are, yeah. So,
well, I mean, how many different things got recategorized once, like into different families or different orders or different groups?
It happens every year. Yeah, when things are constantly being shifted as we learn more.
We didn't have DNA, and now we do. And it's like, oh, well, now we can figure out who shares the most amount of DNA.
Yeah.
Wild.
So to his credit, he didn't just form this idea of like how to divide species up and then be like, all right, I'm done. That's it. You can actually see through his writing that his ideas evolved and changed over time as he got better and better information. So that's really interesting to see that he was kept on trying to refine it and be like, ooh, my first idea, forget that. This isn't the new idea. So he was part of that process of refining our knowledge over time. He was a scientist who was working to improve his system as information
That's
changed.
what science is.
He was, unfortunately, certainly informed by the racism of his time, though. His descriptions of each subspecies of humans is particularly distasteful. I'm not even going to read them here. Ooh. You can search them out online if you're really curious. But I think that the mistakes he made highlight a central idea of science. And that's that we have to start somewhere. We make our best attempt to describe the world, and we try as hard as we can to remove our own biases and cultural hangups. But being impartial and being aware of our own biases is really, really hard. We've certainly got a lot better about it over time, right? And if the mistakes that he made, if you made them now, you would be drummed out of the field. I mean,
you'd be shunned.
Because the science has become much more rigorous over time in how we do these things. And so I think we've certainly got a lot better about it over time as we become more aware of the importance to good science. But even the topics we choose to research are informed by our current culture and society, right? So there are certainly 100%. Scientific biases that we have now that will likely be harshly judged by the future. And we're just completely blind to the fact that people are going to be like, I can't believe you guys didn't study this.
You spent so much time on this.
Exactly. There are likely things we are getting wrong right now because of our blind spots. And we don't know what they are because we're not in the future yet to know, it's hard to get around your own culture and your own biases. And it's something scientists work on a lot and have to always be working on to make sure that we want the science to just be the facts, and it's very difficult. So my thoughts this week have been a little bit winding, but I wanted to think about humans' place in nature and how our thoughts about it have changed over time. So looking at how we view ourselves in relation to the rest of nature is a fascinating way to take a snapshot of a culture's current place in time and history. Our current view is a reflection of our current society as well. And I'll leave you with a thought. For every second grader that grows up learning humans are animals, there are many who grow up never learning it and still believing in human exceptionalism. They grow up believing humans are not governed by the rules of nature. And as we face climate change and other environmental crises, we can see in the slow response or the unwillingness to accept that we too are governed by the same rules that affect all animals on Earth, that ideas that were popular thousands of years ago on human exceptionalism and separation from nature persist to this day. And that is probably not a great thing. Carl's ideas about the different subspecies of humans seem strange to us today, but likely some of our ideas will seem strange to those in the future. Our view of humans and our place in nature is shaped by our culture. And while science has worked to be impartial and remove those cultural views that cloud the truth, we too are governed by the culture of our time and will be judged by those in the future, both by our actions and by our inactions.
Very profound, Kirk.
Well, it's getting a little heavy there, but it has huge implications for us as a species. There's that word.
It really
species.
does. Well,
look.
Also, what two existential crises in 2 weeks.
Yeah. Sorry.
Yeah.
Hope yours is a little more lighthearted. I'm
gonna start that tally. I still haven't started that. Well, it should be. It should be fun.
Great. Well, let's go to a break. Give her a little palate cleanser. Take a breath, and we'll come back and we'll hear from Rachel. Strange by Nature podcast is brought to you by listeners like you who have joined the Society of Strange, our membership group on over at patreon.com/strangebynature. Society of Strange members can join at one of 3 different membership levels and help support the show and also get some fun stuff like water bottle stickers or access to super secret content. So thank you to those who have joined already to help make this podcast possible. If you haven't joined yet, we'll see you soon over at the Society of Strange at Patreon.com/strangebynature. See you soon.
All right, this week I also have a little bit of a different topic for what I normally do. I decided to try something a little new this week.
Okay.
But it's really funny that you were talking about Carl Linnaeus this week and the classification of people, because I wanted to talk about something that doesn't necessarily break those boxes, but is a phenomenon that goes into convergent evolution quite a bit.
Ooh, okay,
have you ever heard of carcinization?
Is this everything turning into crabs?
Yeah.
Okay, I episode 127. There it is. I knew this was going to happen. I literally was thinking about this last week when I was thinking about last week's episode with exobiology or astrobiology, and this idea of like what's the most likely thing for life to look like. And yeah, on Earth, everything seems to eventually turn into crabs from an evolutionary standpoint. And so I was like, with this person, when that person I read it was asking about what alien life would look like, my first thought was probably crabs.
Crabs.
Yeah. Seems to be
maybe like an insect.
It seems to just really, really work, that body plan. So tell us all about carcinization. Right? For those people who don't know what it is and are like, what are you guys talking about? This is so cool.
Okay, so the other word for it, or at least the word that I've been using for it, is crabification.
Yeah,
I don't think that's I like that word better than carcinization, but carcinization is the official term for it.
Yeah.
So it is an example of convergent evolution, which is generally when two very separate groups they independently evolve certain traits that are the same. Like, for example, how bats and birds and insects all have wings.
Yeah.
For example.
But they're clearly not closely related and did not evolve from the same place.
Right. The pressures that caused that evolution caused that species to evolve that particular trait. I'm not going to get into the very
but they had to evolve it out of the materials available to them. So like if you're a mammal, all you have available is skin. Humans can't grow feathers. So a bat has skin wings, and a bird, which was a reptile, could grow scales, and you can make those scales longer and longer and longer and get feathers, So it's like, and insects, again, different kind of thing, but it's similar structure. Structure follows need, right? Exactly.
So the idea is that in crustaceans, the general structure of a crab, so a flat, round shell, a tail. Apparently, crabs have tails. I didn't know they had tails.
Okay.
They are folded underneath the body. That's generally what that is. And then legs off to the side.
Sure.
It has evolved at least 5 separate times among crustaceans.
That's so amazing.
So generally, it's wild. And it's generally the group that is crabs, lobsters, and shrimp. We don't know why this is happening.
I mean,
scientists it seems to be a very ideal body plan.
Well, that's the thing. If you have underlying genetics that makes certain body structures possible, and then you over millions of years have animals that keep on encountering the same pressures,
right?
Evolution's going to follow the easiest path, and if there's a way to come up with that, it'll keep coming up with that same body plan again and again, because guess what? It's possible with the underlying genetics, and it works.
So crustaceans in particular is a larger group of critters, of animals. They have gone from several different groups of them have looked like a lobster, so like a longer body,
right,
to over time gone shorter and shorter and shorter and folding that tail underneath with a much less prominent tail, creating a crab-like animal.
That makes sense. Okay.
Yeah. So, for example, like it's gotten to the point where scientists have to have like true crabs, and then there's false crabs, and it because it's evolved in so many different ways, it's become an issue. Like for example, like king crab. If you eat that, is not a crab.
King crab is not a crab?
It is a false crab. So it is not a true crab. It is in the same, like, general, it's a crustacean.
So what we're saying from an evolutionary standpoint is it does not share the closest common ancestor of crabs and non-crabs is like not the same.
It's like 300 million years ago was the closest.
Wow. Because normally what you suspect is that there was a common ancestor that was crab-like, and then it evolved into two different crabs. But what they're saying is there was a common ancestor at some point that was not particularly crab-like, and they went off and diverged into two completely separate groups that looked very different from each other. And then over time, they converged back into both looking like crabs, but it was they independently came up with that body plan.
Exactly.
Awesome.
So this has happened like at least 5 different groups of like decapod crustaceans. So crabs with 10 legs or 10
appendages.
Yeah, 10 legs, appendages. So like king crabs, as well as something called a porcelain crab, which are actually more related to lobsters.
Okay.
There's the stone crab, and then hermit crabs actually as well are not true crabs, but they are
hermit crabs are
form.
Pretty wild looking.
They're their own wildness here. Yeah, I don't have like a ton, but like all of these groups like evolved. They had one common ancestor over 300 million years ago. So there's been a ton of time for evolution, but the fact that it's happened within the crustacean group, and these animals have gone from, with different pressure, like similar pressures, I'm sure, because they're all in the ocean. That is one common pressure.
Yep.
That they've gone from being like lobster-like or shrimp-like, and then have slowly turned more and more into a crab. It makes sense, right? When you are looking at a crab and you're in the ocean, you want to have your underbelly protected with a carapace of sorts. You want to have your back protected with another carapace.
Right.
But it is wild that it keeps coming back. It's to the point where there's actually been federal grants given out to study carcinization. It's been the term, by the way, has been in use for like over 140 years, which is really cool.
Cool.
Yeah, which is wild.
Well, I think I would imagine also people are probably studying, like, if this is shown to be such a successful form of locomotion, as you start to look at building robots and rovers for other planets and stuff too, you go, maybe we should look into some sort of decapod type design that looks like a crab. And I've seen a lot of like people experimenting at home building robots and whatnot, and they'll make them sort of more, actually usually they say spider-like, and that
spidery, but it looks like a crab,
and it really is a great form of locomotion, and so it's a tried and true design. I did kind of say at the beginning, sort of jokingly, that like, yeah, if there's alien life in space, it might be crab-like. I think the one thing to be careful here is that, there's a lot of pop culture articles about, all life keeps on evolving into crabs. And you're like, well, no, it's this particular group of crustaceans that
just crustaceans that are doing this, that have similar
have a common ancestor.
Pressures.
So what would be really, if we saw that, unlike your example of convergent evolution, which we do see where we have bats and insects and birds all evolving flight, if we saw mammals and crustaceans and, all these different groups that were all creating crabs,
turning
essentially,
into crab shapes.
that would be even wilder, and that would actually
be wild.
But that would be even more likely to say, okay, there's something just about this body plan that's good for life in general, because we don't see, mammals, for instance, that have this body plan.
No, we don't.
Or birds or things like that. It kind of points us more toward this is maybe the best design you can come up with a crustacean's limited set of, body parts to work with for evolution. But talking last week about sort of the pinnacle of evolution, it could be that is, still the best
right
body plan,
that
that anything, because there could have been other animals that tried to fill those niches that were not crustaceans, and they got outcompeted because this is just such an efficient design for that particular habitat, for example. So yeah, convergent evolution is super, super cool.
Is very cool. And besides all that too, there are actually examples of species like hermit crabs, which I already mentioned, going towards that crab shape and then also moving away from that crab shape.
Probably as the evolutionary pressures change,
Yeah, I mean, hermit crabs, they're famous for getting new shells and everything and using those for their homes. That is a different way to solve the issue that a crab-like body would present for a crustacean creature in the first place.
So cool. Hey y'all, nature's complex. Wild. I don't know if you figured this out yet. It is a wild, strange, complex system that we are so fortunate to be a part of and get to have the intelligence and self-awareness to study. You know what I mean? We are so lucky. This is so amazing that we can just look around and
we'd be
and understand this stuff and be able to study it in a way that some other species can't, and so it's so
Harvard,
we're so lucky.
It's so cool. Harvard University, their evolutionary biology department is looking into this actively. They just published a paper in 2021 in the journal Bioessays, which I could not actually read. But they had a couple of reasons, and their whole idea is not necessarily looking at these species are doing that. They're looking at what drives crustaceans what are the pressures that are in place to drive crustaceans to this shape in the first place.
Cool. Yeah, because it should be you should be able to study that, especially if you have a species with a fairly quick reproductive cycle. Obviously, with things like bacteria and insects, we can do it very quickly. But
it's so easy.
If you have a
crabs,
fairly rapidly reproducing population, you can change some of those pressures and see. You can watch evolution happening. You can watch the bodies change, from generation to generation, and be like, oh, you know what? When the water is warmer, this happens. When the water is colder, this happens. When there is an abundance, when there's more predators, this happens. When there's fewer predators, this happens. You can test all those things. It takes time, but we live in an age where there are people figuring these things out, and you can't read all the research papers fast enough to learn everything that we're learning. So it's a very cool time to be alive.
We don't.
That's why we have this show, so you can tune in.
That is why we have
those papers
show.
for you and let you know about all the weird, amazing stuff happening out there.
Yeah. I'm going to end with this one quote from a researcher. Her name is Joanna Wolf. She's one of the researchers at Harvard University, and I quote, "She thinks of them as like Lego creations. They have many different components that can be swapped out without dramatically changing their features, so it's relatively straightforward for a cylindrical body to flatten out or vice versa. But for better or worse, humans won't be turning into crabs anytime soon."
No, yeah, that's kind of what we talked about. Yeah, we don't have the right number of limbs for one.
No, we don't have the right body shape or anything like that.
We can't create a carapace. So, there's a few issues.
Yeah.
But I have a couple just sources. My shopping habits alone are it's much harder to find clothes that fit
if I had a
crabs.
couple limbs. Oh. I have a couple sources that I'd like to cite this week. I used an article from Scientific American called "Why Do Animals Keep Evolving into Crabs?" which was beautiful. That just came out June 1st. Wikipedia was helpful as always, and then an article from Newsweek. So that's all I have for y'all. Yeah, keep tuning in. We'll see you next week. Bye.
Sounds good. Bye-bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.